All right, so you want to make a Docker. So this is what you do. So there's here we need three things to make this happen. So, first things first, I'm in Ubuntu or Linux Mint, whatever. You've already gone to, let's go back. You want to go to the terminal and you want to see if Docker exists. And if it doesn't, it should give you a prompt on how to install it. And so that'll look something like sudo apt install docker or docker.io or something like this. If you just type in Docker and it doesn't run, it'll usually tell you how to install it. That worked for us the other day. So once you have Docker installed, you should be able to run a command called docker ps. I forget what PS stands for, but it'll list out all the processes that are currently running in Docker, which might not be any for you. But this, I'm getting a permission denied. So this is a classic example where you need to say sudo docker ps. Let me make this bigger so you guys have a chance of seeing it. Terminal. Profile. Nope. I don't know. Oh, zoom in. Haha. Control 4. Maybe one more zoom in. All right, haha. Okay, so sudo docker ps. That, in my case, I have a bunch of different things running. One of it's called an adding server, which is the one I just made. So, anyways, so there you go. So step one, make sure that Docker works on your computer. Step two, you need to write a working server. So we did this the other day. We made this file called server.java, and it just opens up, it listens on port 6666. It waits until somebody connects to it. It will quickly take all their numbers, add it together, and then write back out. That's it. And it'll do that over and over and over again. So I already know this works. I would compile it here, but I don't actually have Java on Ubuntu here. I could install it by looking up, Googling how to do it, but I'm not going to worry about it, because inside Docker I'll be able to compile it, because I'll get a version of Docker. I'll start off of a base Docker image that can compile something. Okay, moving on. So that works. The next thing you need is a thing called a Docker file. It needs to start with a capital D, no extensions. So Docker file, we're going to open up that in Genie, and in this case I would suggest using something very similar to this. So I found somebody else already made something. There's an official package called the OpenJDK. So I don't know if you know all the background, but Oracle owns Java, and they put out the official JDK, but it's not open source. But you know, Linux wants everything to be open source. And so actually Oracle helps support the OpenJDK project now, I believe. And so basically it's an open source port of everything. It doesn't have everything that the regular JDK has, but as far as we're concerned, they're pretty much the same thing. Okay, and then you can tell it to copy something. There's a bunch of different commands you can do. This is a good kind of smattering of what you might do. So you can have more than one copy command, more than any one of these lines you could have more of. So I'm going to copy everything in the current directory to some random folder in in the image. I could change this to whatever I want. In this case, my app works fine. I could call that anything. Okay, and then I want to be able to run some commands, but I need to run them in a particular directory so I don't have to do fully justified commands. So I'm going to set the working directory to be in that folder. And then I'm going to compile that Java program that I've uploaded with this dot, because the Docker file is in the same folder, server.java. As a little side thing is this image is going to end up getting the Docker file and this other script that I wrote here inside of it. I could make another folder and copy that over, so I'm only copying what I want, but it's not going to hurt to have these very small files in there too. It's going to make my thing 200 kilobytes or 200 bytes bigger than it needs to be. Okay, moving on. And then you can, I could use a command and run are like two of the same, like they practically do the same thing. One, you have to use this array notation where you separate all the different chunks and run. Anyways, there is a difference, but not one that matters to us. So anyways, here we go. Well, actually, here's the difference. Run is what's going to happen before, while you're building up the image. So these are all image build things, and CMD is what gets called whenever you start up the Docker container. So these are building everything up, and so you get everything ready to go. And then this one is what happens whenever you finally spool it up and tell it to go. In this case, it's going to run the server. So I'm going to make it where if anything goes wrong, it'll just start it right back up. So every time so something airs out, the Docker image will shut down, and then it'll try to start right back up, and it'll call on Java to run server. Anyways, there you go. If you have something more complicated where you wanted to do more than just run server, you could have this run a script. You can have it do whatever you want. But you need to have some entry point. A little side note on how Docker works. Docker is kind of a simplified model of how a regular operating system works. Usually operating system, you have lots of different processes, and then you can flip between them. But in a Docker image, it doesn't have to be this way, but they usually expect that you have one entry point and essentially one process. So in this case, we're going to run Java, and that's all we're going to run. It's just Java with this program. So it's not going to have all the overhead of thinking about all the other tasks it's doing and flipping between them. So anyways, I don't know if that makes sense, but there you go. So pretty simple Docker file. You can see here I picked OpenJDK. How did I figure out that? Let me do a little aside. Okay, so there is this thing called Docker Hub. And I'll just search for JDK. Bam. Anyways, the first link comes up to OpenJDK. There's also a Java SE JDK. Let's just click on that one. So Microsoft has built this thing called the Java Standard Edition JDK. So what this is some flavor of Linux. I don't know what. And they've gone ahead and added stuff where you can compile Java programs. We can go down and read the description. The Zulu OpenJDK for Azure Docker images. Okay, so Microsoft built this so they can use it with their cloud services. Anyways. And there's all sorts of different flavors of it if you want. These are all different versions of Linux that you can that they build it for. So maybe you like working in Alpine or CentOS or Debian. Anyways, in our case, we don't care. Whenever you let's see. Anyway, so if you say your image is, let's see, pull This one's not a clean example. That has a really long name, and then you can put all these tags on it. Anyways, let's go look at the OpenJDK one. This one's a lot cleaner. Okay, so this one's a little, this is a official Docker image. It's nice to build things off the official ones, so you don't have to do too much. Anyways, they work. If it says official Docker image, you're good. So. Anyways, OpenJDK, if you want one to run a little website, you can get a PHP one or Nginx one or whatever you want. Anyways, hit me up if you are wanting to do some kind of project that can help you figure out how to piece together the right pieces. I'm learning with Docker just like you guys are. But anyways, OpenJDK, if I want to use it, here's an example, which should look very familiar. Here is an example Docker file that you can make. So here you say it says from OpenJDK 7. You can change that to 10, 13, whatever number you want. So this is using Java 7, which is kind of an outdated one, but it does all the stuff that we need it to do. So I didn't bother asking for a more updated version. Anyways, I think you can just leave that off and it'll just get whatever random one is the most recent one. Anyways, I just copied that. They usually tell you how to use it. They even tell you how to build it and run it. I don't want to run it like this. I'll show you what my startup script looks like, and then we'll go from there. All right, so we got a Docker file, we got this, and then I got a script. And there's a few commands here, so I make a script to make this a lot easier. And I also use this as part of my deploy process, mostly for High School Hack. So I'm going to use the same deploy services that I built up for High School Hack, and so all your things have to, your startup script has to be called start Docker. And so basically I upload your folder up to all the servers, and then I go through and have them run a script called start all, which goes to all the folders and looks in them and looks for something called start Docker and runs it. Anyways, it's a whole thing. But anyways, these commands should be fairly easy to understand. So there's all sorts of things you can do with Docker. You can stop stop a Docker container. You can remove an image. You can do all these different things. So anyways, I'm going to stop if there is a current container called adding server. That's nice if I already have it running and I want to update it and rebuild it from scratch. So I like to stop it and remove it. So I'll do that. And then I can build it. So Docker build. I forget what the dash T means, oh, that's the tag. So I'm going to build it and I'm going to give it the name adding server. And I forget what that dot is. Oh, that's the folder we're in. So what folder are you going to go to get the Docker file? And so the Docker file is in this folder. So in this case, it's going to build the Docker file that's in this folder and name it adding server. That dot's very important, otherwise it doesn't work. Okay, so in theory, that will build it. It doesn't always work. Anyways, it'll give you an error message if it doesn't work, and then you have to kind of hunt it down. All right, the next thing you need to do is you need to run it. So there's a lot going on here. So let me take you through bit by bit. So Docker, side note, this builds it up. So I have it assembled everything it needs and it's ready to run whenever you need to, but it's not running yet. So if you say Docker run, it'll actually run that program. So this is kind of like downloading your program from the internet, because it gets OpenJDK, copies the file over, does all that stuff. But anyways, so here we're going to run, and we're going to run it in detached mode. What that does is it lets me run it, and then I can close whatever terminal I'm in, and it'll keep on running. If I don't have that, then as soon as I close whatever terminal I started it with, then it'll kill off this process. I do not want that. This next bit, I want to restart always. Sometimes can get problematic. So if you have something glitchy that will break all the time, like break immediately, and you restart always, you'll get in this infinite restart loop. And I can't actually remember how I fixed that in the past. I've had to deal with it a couple times, and every time I have to like do some research to figure out how to deal with it. But that could be a problem. So I would suggest leaving that little bit off until you actually get it to work. And the way I'm writing this one is you shouldn't actually need this. In theory, your thing should stay up always, and if anything fails, there's a try catch on the server side, but you never know. That's a nice way that you can be a little failure tolerant. It's amazing how easy it is to make something brittle, but that can save your butt a lot. I use that on high school hack challenges all the time, and if I forget to put that, I'll give you a 50-50 chance that the challenge will go down, probably, because people are trying to do things to mess with it. That's part of the hacking thing. Okay, and then this is port forwarding. So by default, you don't have any access into it. It's like, Schrodinger's box. You can't. Nothing goes in, nothing comes out. But here, I'm going to poke a hole. So from the inside, it'll seem like there's a hole where you can send something out on port 6066. That's the right-hand side here. But on the outside, it will change that port to port 7777. So on the outside, if you go to port 7777, it'll get you to the thing that's running on the inside. So the way we set up the server on the inside, it's listening to port 6666, and so anyways, I could have used the exact same port. Anyways, but sometimes, sometimes you need to change it up. You might have a lot of different services that all operate on the inside pretty much the same. Like if you have a web server, it's going to listen on port 80. But if you have multiple web servers running on this, you need to have them all have different ports. And so, anyways, there you go. So then I need to give it a name, and I need to tell it what container to run it from. So in this case, I have the same name as the name of the container, the image that I'm going to get to run it. So anyways, there you go. This, in theory, should do it all. One note, whenever you pick your name, you can't pick anything with an uppercase, just lowercase only. I think you could do underscore, but I can't remember. But anyways, lowercase only. I'm pretty sure you can do underscore. Okay, so that's a lot of background. I'm going to open up Terminal, and let's zoom in, zoom. Control plus, Control plus. Okay, if I say Docker PS, it's not going to work. Can I do this? Okay, so lots of things running. I'm going to stop that adding server and remove it. So I'm just going to do this manually so you can see it. So sudo docker stop adding server. Okay, and then I'm going to say sudo docker remove adding server. Okay, so Docker PS. All right, so you can see that there is no I have other things running, but no adding server. All right, so at this point, I want to get it running, and I have a script right there called start Docker, and you can say start Docker, and it won't work. So what you have to do is you have to say sudo /start docker.sh. So the / is the folder you're in, and then the name of the anyways, if you don't do the /, you can actually execute the script. I don't know exactly why you have to do that, but if you want to run a script, you have to do that. Sometimes that doesn't work, and you have to say sudo bash start docker.sh. Anyways, this ran through super fast. Yours is not going to run through super fast because the JDK is quite big. And so it's going to take a while to do all the downloading things. So you have to have a good open connection, and it might take a while. But it's going to run through each of the lines, and it'll give you a little hash after each one that's successful. And each of those hashes are actually things that get stored on your computer. So say you make another one where you change step 4. Well, step 3 is still good, so you don't have to redo that one, and then you just have to do a different step 4. You don't need to know that, but behind the scenes, it's super efficient on the way it stores things. It doesn't just store like one image. It stores all the steps it takes to get to that image, and if you ever have a different one that you shares some of those steps, then you don't have to store all of it. Anyways, so it went through each of these steps, and if any one of these failed, like for instance, you couldn't compile something, it would give you an error message, and you could see that. So let me go mess it up. Let's forget a curly brace. All right. So I'm going to run it through. All right, there you go. It exited out, and it gave you an error message. Did not get to step 5 out of 5. So anyways, we'll go back, save that, run that. Anyways, the nice thing about the script, you can see that I can just run it over and over and over, make a change. I don't have to do the stop and the remove, and anyways, it's just a one easy run thing, and it takes care of everything. Okay, so now I can do a sudo docker ps again. I can see that it's running, and I could test it out if I had the client here, but I don't have a client here. I was too lazy to copy it over, plus I don't have a JDK, like Java doesn't, Java exists, but Java C doesn't exist here, and you can see that I have a few different ways I can install it, but I'm just too lazy and I'm not going to do that. So I'm going to exit out of this Linux side, and I'm going to go onto the Windows side. And I'm going to run it from that side. A few things to note: if you're going to do that, there's some complications. You have to figure out the IP number of your virtual machine. So ifconfig, that's like ipconfig. In Windows, you say ipconfig. In Mac and Linux, you say ifconfig, and it'll print out a whole bunch of things. You're looking for something that says inet without a 6. We want to get just an IP4 address, and it'll look like a normal IP address. So I'm scanning up and up and up and up and up, and let's find an IP address. Well, we got local. That's not helpful. And here we go. This one happens to be called ENPOS3. I don't know why it's called that, but here we go. We got an inet address, an IP address, 1032.62.10. So, in Windows, you can just highlight something and hit enter, and it copies it. But in Linux, you have to actually, how do you copy? Control-Shift-C. So, anyways, there you go. So I need to have that IP, and before all this gets started, let me get out a full screen here. Let's go to So also the VM that you're in, if you go to if you go to its settings and you go to its network, it needs to. Well, if you have problems, come and check this out. I believe you need to have a bridged adapter for this to work. You can do, if you did NAT, that's network address translation, then ports get changed and all sorts of things like this. There's different settings you can do. Bridged adapters, what I'm going to do. So before you start up your Linux VM, you can make sure that you're attaching to it in that way. In theory, you can actually have multiple ways you attach to it. Not that that's super important. Okay, so there's that. There's also firewall considerations. So I'm going to turn my firewall on and see if it's a problem, but you might have to turn your firewall off. So just keep that in your mind, that the firewall may cause you problems. All right. So I have a client. You can see that I've already populated out the IP address to the VM. So that'll get me into the Linux. And then I tell it port 7777. I compile, I run this, and it works. That hardly ever happens. If I change this to some other port, the old one, it says connection refused. And let's change let's put some numbers in here. All right, that works. Let's crash it. Is it giving me the answer up to the crash? That's 1, okay. So it's crash tolerant, or anyways, I don't like that behavior. That wouldn't be what I want it to do, but at least it's not crashing, and I would like to know when things actually go wrong. It's actually really bad to have a program that will, just happily tell you the wrong answer and not crash. In this case, the appropriate response is to crash or send me back a message that says couldn't do it, right? To actually send a number back is disingenuous at best. All right, so we already did client server. I already talked about threading. So you can do that on the client side, where you make a bunch of different threads that go out to. In this case, all you're gonna have to do is change out a whole bunch of different. I'll give you a block of 32 IP addresses to go to, and you need to test it locally and make sure it works before you can have a chance of it deploying, right? But yeah. So basically, you'll just, and they're all sequential. So there's like port, it'll be, I forget what the addresses are. I'll have to find them. High school hack. I forget what I call. Anyways, I'll have to get back to you on what the addresses are. Anyways, but the first one's 01, the next one's 02, and the next. Anyways, the first three, whatever these, I think they're called octets or whatnot. Those are already set, and then you just have to change this as from 1 all the way up to 32. And then you can use the same port for every single one. Once you give me a Docker image, I can then just easily deploy it to all the different servers. Oh, I know where I can go look. Control F. Okay, High School Hack 2019, deploy, open. So that is going to go from 2001 to 2032. Okay. So, I think you can even see passwords there. I'll get this posted once I'll send you an email once I get yours deployed. But 12.157.27.201 will be the very first one, and then it will go all the way up to 232. So each of those will have one core at its disposal, and so you can easily just have 32 threads and ask them each to do something, and each of them can take a minute to do whatever calculation, get back to you, and then you send another chunk out to them. Anyways, there you go. Don't save this. Okay, so let's kind of rehash this a little bit. You have some kind of Linux VM. You get Docker installed. Step 1. Step 2 is you get a client server already set up, and you work that, and you can do all that in Windows and make sure it works localhost, all that good stuff. Okay, then step 3 is you can just come over here in Linux and steal pretty much steal this code right here for the Docker file, capital D. And you can pretty much steal this script for the start Docker. You can pick whatever port you want. Obviously, you can't pick. You guys can all pick the same one. Pick something random. If it's something I'm already using, then I'll judiciously change it, and then I'll let you know what it's actually at. Whatever you name it's not super important, although you guys can't all name yours the same either. So you guys all have to have unique names for your things. And again, I will judiciously change that if I feel the need to. Anyways, there you go. And that's it. Oh, well, and then you can go to the terminal. Well, back. In this, I just have to right click and say open terminal. But anyways, I can get to the terminal in that folder, and you will want to start it up. You'd have to say sudo bash start docker.sh or something like this. Bash. And then you want to get it where it gets through all 5 steps, say successfully built, and then give you this nice long hash code. You don't need to remember that, but if it gives you this big long hash at the end, then you're successful. If you don't, then you weren't successful, and you got to figure out where you went wrong in each of these steps. Anyways, I don't know what to tell you guys other than just to kind of get in there and do it. There's all sorts of gotchas here and there for Docker stuff, but once you get it to where it works for you in one situation, there you can do like just this. If you can get this to work, you can do any kind of Java service that you want with very minimal modifications. You can just change the Java program, and you get this, and you get a way to deploy a Java service like that. Obviously, you're going to want to start getting more sophisticated and have them do more things than just run a Java program, and you can do that. You can running web servers through Docker's kind of is very common. Whatever you need. So, anyways, I'm going to stop talking now, and hopefully that gives you guys some stuff that you can work on. If you choose to do this, why don't you guys in an email zip up all your Docker stuff, send it to me, I'll validate it, push it out, and then I'll send you back a notification that everything's live. And once you also do that, I'll also tell you what the encoded string is. and I will give you a range to check for a range of acceptable passwords or keys, just like I did in the threading example. So anyways, and then you can figure out what the secret message is. I'm not so worried about what the key is. I want to know what the message is. And yeah, anyways, that's it. Hopefully you guys are motivated and have time to work on this. I think it's worthwhile to know this stuff. I hope you guys hope it doesn't seem too complex. The complexity comes in the gotchas and knowing whenever things go wrong how to fix it. And it's hard to teach to that because I'm personally am still learning a lot of things in Docker, but it starts making more and more sense as you work with it more and more. And I think I can't really overstate how big Docker is in the world of computer science right now, and how it's really kind of taken over the world. If I had to give somebody a suggestion on what they need to learn to be a valuable computer scientist, one would just be to know basic syntax of Java or Python. Step 2 would be able to know how to do some web programming, and then once you guys can do those 2 things, then the very next thing I would put on that list is to learn how to build some complicated things with Docker. Start piecing together services and whatnot. Anyways, I'm gonna stop yammering. Hope that helps. This will be the last lecture, I guess. You guys have a good summer, and I hope to see you guys at graduation. I think we're gonna have one in August. So anyways, enjoyed having you guys, and take it easy.